This is Unit 3 and bisectors of triangles. So first off, we need to refresh our memories as to what a perpendicular bisector is. A perpendicular bisector is a line that intersects a line segment at its midpoint and also forms a 90-degree angle. So for example, if here we have a line segment, perpendicular bisector would need to intersect at its midpoint, so the two sides would be congruent, and it would need to have a 90-degree angle. Concurrent lines is where three or more lines intersect at a common point and the point of concurrency is the intersection point of our concurrent lines. So for example, if we have three lines here that all are intersecting at the same point, we would call these concurrent lines. And this point right here where they all intersect is called the point of concurrency. The circumcenter is the point of concurrency for the three perpendicular bisectors of a triangle. So I'll sketch this out. Here's a triangle. And so we need to draw the three perpendicular bisectors of each side. So that looks like it's about the midpoint and perpendicular. Okay. Over here, this looks like it's about the midpoint and perpendicular. And our third side, here looks like it's about the midpoint and perpendicular. So here, where those three lines intersect, right here, see those three lines are intersecting? This is the circumcenter. Okay? And then we have the circumcenter theorem, which tells us that the circumcenter is equidistant from the vertices of the triangle. So if we want to add to this diagram, here we need to draw in from the circumcenter to each vertex. So if we draw in those segments right there, those segments should all be equidistant to each other. So those segments are all congruent to one another. We are also going to be talking about the angle bisector and the angle bisector theorem today. So an angle bisector, recall this is just a ray that splits an angle into two congruent angles. Okay, so here we have an angle. An angle bisector is going to split the angle into two congruent angles, just like so. The angle bisector theorem tells us if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. So if I pick some points here, we'll call this point A. And if I go A to each side of the angle, remember when we talk about distance, it always has to form a 90 with the line, so there. Those two should be equidistant from one another. When we are dealing with the angle bisector theorem, we can also discuss its converse. So what that means is essentially the statement that we have, but in reverse. So the angle bisector theorem would also tell us if a point in the interior of an angle is equidistant from the sides of the angle, then it is on the bisector of the angle. So that's our angle bisector theorem. So if at any point in time we have a point somewhere on the interior of our angle, like here, this point A, and we know it is equidistant to both sides, then it is a bisector. Okay? And our last new vocab word for today, before we do some examples, is in-center. In-center is just referring to the point of concurrency of the three angle bisectors in a triangle. So we'll draw a little diagram to illustrate this. So here we have a triangle. Okay, so each angle is going to have an angle bisector. So if we take this angle down here and if we bisect it, so split it off into its two congruent parts. This angle over here, if we bisect it, split it off to its two congruent parts. And this third one, we bisect it, so split it off into its two congruent parts. They should all intersect at one common point. And this one common point is then called the in-center. Okay, so we need to remember a few things here. We need to remember that angle bisectors go with in-centers. Okay, so if we have three angle bisectors, their point of concurrency is an in-center. And perpendicular bisectors go with the circumcenter. Okay, so if we have three perpendicular bisectors, their intersection point is the circumcenter. Three angle bisectors, their intersection point is the in-center. So now we'll do some examples with this. Our first example here, we are told that GI is a perpendicular bisector. So right there, whenever we have a definition, that should clue us into the fact that we need to be doing some labeling on our diagram. So GI is a perpendicular bisector. We're going to find x and y. If EH is 16, FH is 6x minus 5, EG is 3.2y minus 1, and FG is 2y plus 5. So GI, let's locate that. GI, it's a perpendicular bisector. So it's going to bisect. So two congruent parts, so GE should be congruent to GF, and it's perpendicular. So we're going to label both of those. Now we're going to go through and label the rest of our diagram. So here we're told that EH is 16, FH is 6x minus 5, EG is 3.2y minus 1, and FG is 2y plus 5. Well, notice right here, it should be very clear that 3.2y minus 1 should be equal to 2y plus 5 because they are both marked as congruent. So that will be our first equation, and we can solve for y. So 3.2y minus 1 should be equal to 2y plus 5. Solving for y, so we would subtract 2y, giving us 1.2. Y minus 1 is equal to 5. Add the 1. So So 1.2y is equal to 6. And then to get the y alone, we'll have to divide by 1.2. And 6 divided by 1.2 is 5. So here we just figured out that y should be 5. Okay, so let's decide how we can find x. Well, if we take a look here at these two segments that we have left, we have EH here left and we have HF. Now, if we knew that point H was the circumcenter, we could definitely say these two are equal to each other because circumcenters are equidistant from the vertices. But we're not given that information. Instead, let's take a look at these two little triangles. Here's a side that's congruent. They both have the angle congruent because they would both be 90. And GH would share itself. It's congruent to itself. So these two little triangles are congruent by side angle side. So therefore, their two hypotenuses must be. So we can make the equation up of 16 equals 6x minus 5. And then we just have to solve this. So to solve this, we'd have to add the 5 over. And so we would have 21 is equal to 6x. And then to get the x alone, we'd have to divide by 6. So x is equal to 3.5 or 3.5. You can express it either way. So there we solved it using the fact that GI was a perpendicular bisector. Okay, our next example, point A, we're told is the in-center. And so in-center is a vocab word, so that's going to help us get some measurements here. We want to find out what AU is, angle ARU, and angle QPK is. So, for starters, let's take a look at what we know. If A is the in-center, and A is right here, that tells us that each of the vertices were split equally. So those two are congruent, these two are congruent, and these two are congruent. Well, right up here we'd be able to probably figure out what x is, which would definitely help us out. So we're going to start off by solving for x. Those two should be congruent, so we'd say 3x plus 2 is equal to 4x minus 9. So we want to subtract our 3x. So we have 2 is equal to x minus 9. Add our 9. So x is equal to 11. Okay, now here we aren't asked for x, but we're asked for angle measures. Since we want angle measures, we're going to have to plug this 11 back into either one of those. So we'll plug it back into 3x plus 2. So 3 times 11 plus 2. 3 times 11 is 33. Plus 2 is 35 degrees. So each of those angle measures is 35 degrees. Here we're asked for angle ARU, ARU, and angle QPK. QPK. Well, based off of what we just found, we found angle QPK is 35 degrees. Okay. ARU, so ARU is this angle right here, which we've marked as congruent to this 40 degrees. So angle ARU has to be 40 degrees. So there we found those two measurements. And there is one small typo here. We don't really want to find AU. We really wanted to find a third angle of angle KQT. So let's find that third angle of KQT. Well, we know that 3 angles of a triangle have to add to be 180. So what we can do is we already know what two of the angles are. This full angle here, 40 plus 40 is 80 degrees. This whole angle here, 35 plus 35 is 70 degrees. So we can take 70 plus 80 to give us 150 degrees. Three angles have to add up to be 180, so we can subtract from 180 to get 30 degrees. And our third angle, angle KQT then would be 30 degrees.